All right, welcome to Moonwatch. So today we're going to look at the activity portion of Moonwatch. At this point, you should have already read through the introduction, so it's already introduced terms such as waxing, waning. We've already looked at gibbous, crescent, and your quarter moons as well. Now the materials that you'll need for this is the Lunar Layout sheet. You will get one of these in your kit that's already laminated. I would recommend, if you're going to do this in stations, already go ahead and pre-make copies of this Lunar Layout sheet. Have it laminated, and it will already last a lot longer. One of the other things that you'll need is a ping pong ball, and you want to have these colored so that half of it is in darkness and the other half is in light. You'll need a little tacky adhesive. So some of that poster tack would work great. Just put a little on the bottom just so that when you lay it out, you can pick it up and demonstrate to the students and show it to them without it actually falling off. It'll be a lot easier to be able to take our measurements that way. And finally, you will need a protractor. Now this particular protractor with the hole in the bottom is going to work really, really well because of that crosshair right over there. So you'll be able to line up all of your measurements really well if you get the protractor that does have that hole in there. Just a suggestion, okay? So in our procedures, the first thing that we're gonna do is you're gonna get your ping pong ball. And if you look at the Lunar Layout sheet, it shows that the direction of the sun's rays, so the sun is somewhere off to the left, shining towards the moon. So that means that you would put the illuminated side of the moon facing towards the sun, the dark side of the moon facing away from the sun. Now at every single location, when we move it to 2, 3, 4, 5, 6, that direction stays the same. Okay? Make sure that the moon is always facing towards the sun, which will be to the left of your lunar sheet. Okay? So the moon will never actually turn. It'll just rotate around with the earth being in the middle. Okay? So the first thing we'll do is we'll put the moon facing the sun in position number 1. At position number 1, we get our protractor. And then, like I was mentioning with the crosshairs, you want to line up the bottom to this line right over here between the numbers 4 and 10. You want to make sure it's right over there. And then you'll see that the other one will line up with the lines for 1 and 7. That's how you'll know that you're perfectly square. At position 1, there is a 0 degree in angle between where the sun is located and the earth and the moon. They are in a straight line, 0 degrees. So on our student sheet, under data and observations, okay, on the sketch of the moon, you would show that it's fully illuminated. There is no shading there. The angle measurement would have been 0 for location 1. And the phase name, when you look up at the location from the earth, and this is where having that tack really works out well, is if the student looks at the moon from the location of the earth, looking directly at it, they see that it is completely in darkness. The side of the moon that's illuminated is facing the sun, so this would be our new moon. And so under phase name, the student would write in new moon, okay? So that is the first one, just to kind of give you an idea of how to get it done. Let's look at position 4. Let's just skip a few over here and get to position 4. So once we move it to that 4th position, you stick the moon back there. You see that it is in line. The illuminated side is still facing the sun. The dark side is facing away. And then we add our protractor to the middle. Once again, with having that hole, it makes it really easy to line up right over there facing the sun. And we see that if the sun is over here and now where the moon is now, it has shifted 90 degrees from its original position to where it is at position 4. Now with this 90-degree position change at 4, when the students look at the moon from the location of the earth, that is exactly what they will see. Over here we write down that it is a 90-degree position change, and they're looking at the first quarter. Now to illustrate that to them, once again, they can pick up this actual lunar layout sheet And if they look at it from their location on the Earth, directly at the moon, that is the moon phase that they will see, is a first quarter. Now, as you progress through, after you pass number 7, the next angles, because we're using a protractor, we have to add our original 180 degrees. So every single number that we look at after 7, position 8, 9, 10, 11, and 12, when you are adding your information to your chart, you must remember to add the original 180 degrees after position 7, because the protractor will only calculate up to 180. So looking at number 8, for example, we lay it on the tacky spot. We get our crosshairs aligned over here, and we see here's our original 180 degrees. Okay. There is the 180 at position 7. We've already passed all of these 180 degrees, so we need to add a few more. So using this bottom line now to align between 2 and 8 to make sure that I'm square, and between 5 and 11, I see that now it has added another 31 degrees. So you would add that 31 degrees to the original 180. And for position 8, 180 plus that 31 degrees puts us at 211 degrees with our waning gibbous. And once again, the students can lift this up, and if they look at the moon from their location on Earth at this position, they will see over there the waning gibbous. And once they have their chart completed, you will have an illustration over here. I love that this has 12 different locations as opposed to just the 8 phases, because it goes to show to the students that within the lunar cycle, you can look up at the sky and actually see the same phase last more than one day. Okay? And then over here you have your angle of measure between the moon and its position, and also the phase of the moon listed over here. Once you've got this chart complete, you are ready for your 6 conclusion questions at the end of this. So this is a good lab, I think, for after you do and you show the students how to do it, and then you guys work on one together to get a fist of 4. Okay, so if they're showing you a 0, it means, look, even with their help, I still don't kind of understand what they're doing. Gauge with them as you're going through to see how their level of comfortability is with this activity. Or maybe they're at a 1. I'm starting to get it, but I'm still a little confused. Like, I see the angle, but could you show me how to read the protractor? Okay. Maybe they're at a 2. I can do this with help or an example in front of me. So maybe they just need that closer one-on-one of you going by and showing them at their own desk how to get it done. Maybe I can do this on my own and I can show I understand. So at this level, if they're at a 3, they're pretty comfortable with it. They can complete their work. Now, if they're at a 4, I'm very confident with this and I can teach someone how to do this. They're the student that's already going to be helping you by assisting the other kids in their group. And so a fist of 4 over here, which is a quick check that you can just ask your students, all right, fist of 4, where's your level of comfortability with this? And you can just see the numbers as they raise their hands, how good they're feeling and what you may have to explain a little bit more. Now, after Moonwatch, there's a great article that matches really well with the history curriculum for 6th grade called The Tides of War. And it's a great article to show how scientists and the war generals used scientific data to decide when they were going to attack on D-Day. So great add-on lesson to go with this. So after that, we've got your conclusion questions, and then also be sure to watch the video on Moonwatch as a 5E to see how you could put this activity in with several others to get a fully comprehensive moon unit.